Okay, this is Business Cal homework number 3, homework with chapter 3. I'll be solving number 10, which says consider the function as representing the values of ounce of silver in rubles as a function of time in t days. Find the average rates of change of r of t over the time interval t to r to t plus h. So the interval, we're trying to find from t all the way to t plus h. Okay, and we're told that h will be 1, 0.1, and 0.01 days. Hence, estimate the instantaneous rate of change of r at any time t. At time t, specifying the units of measurement, smaller values. Just make sure you check for h. All right, and the function they give us is r of t equals 80 plus 18 t cubed, and we're told that t is 1. Okay, so the find the average rate of change. Average rate of change, that formula will be r of t plus h minus r of t, all divided by h. Okay, so what we need here is to put t plus h for all the t's first. So this will be 80 plus 18 t plus h to the third power minus r of t, which is the original formula. So we'll put a parentheses here, minus 80 plus 18 t to the third power, and we'll close that parenthesis there, and everything will be over h. Alright, this is our formula. Now, let's tell the calculator that t is going to be 1 and h is going to be 1. So, let's turn this on here. And so 1 store into alpha t. Where's my alpha t? There's a t. So alpha t. And then h, I want that to be 1. So 1, store that into alpha h. Okay, so the calculator believes that t and h are now 1. Okay, now let's put this expression in. I'm going to start this expression off with a parenthesis for the calculator. So parenthesis 80 plus 18 open parenthesis alpha t plus alpha h, close that quantity. Now we want to cube that, so I'll raise that to the third power, and minus another parenthesis 80 plus 18, and then t, so alpha t, and that's going to be to the third power, and then we're going to close that parenthesis, and then let's close the entire numerator. Okay, and then we're going to divide that by alpha h. Okay, and what we get is 126 from this. So all this is when h is 1. So when h was 1, we got 126. Now let's change h to 0.1. So I'll do 0.1 store alpha h. Now I'll bring my equation back by pressing second function and then, sorry, it's hard to see that. Okay, again, I put 0.1 store h. And now I'm going to bring that equation back here by pressing second function and then enter. And then second function, enter again, until it appears on the screen. And now that it's appeared, I want to press enter. And my value now is 59.58. Now I'm going to store 0.01 store into my h here. So alpha h. So now h is 0.01. Now I'm going to bring back my equation by going to second function, enter, and then second function, enter. There's the equation now. Now press enter. And now I'm getting a 54.54. Okay. Now, they also asked, 1/8. Let me put some more decimals here. So 1/8. Okay, so those are the three answers they're asking us for. what would the average rate of change be? The average rate of change be if we put in h is 1. The average rate of change for h is 0.1 is here. Average rate of h of the function if h is 0.01 is here, 54.5418. Now, they want us to see if we can find the instantaneous rate of change. Instantaneous rate of change I can find by putting an ever smaller h. So I'm going to put a really, 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 really small h in here. So 0.0000, 4 zeros, and then a 1. I'm going to store that into h. So alpha h. Here's my h. Okay. And then let's go back to the function. Second function, enter. Second function, enter. The equation is back. And now we get about 54.00054. So I'm going to say this is approximately, it's going to be 54 for the instantaneous rate of change. Okay, now let's look at another problem. This will be problem number, let's see, we need problem number 28. Okay, so let's look that up a little bit. Problem number 28. Find the equation of the tangent line to the graph of the given function at the point with the given x coordinate. Then sketch the curve of the graph with the approximate tangent line. Well, first of all, we're given the function f of x equals 8x plus 3 over x, and we're told we're at the point x equals 2. All right. Well, to find the slope of this, we need to take a derivative. Before we take a derivative, we need to make this into an so we use the power rule on this. So this will be f of x equals 8x plus 3x to the negative 1, and now we can use power rule. So the derivative here will be this will be to the first this to the first power goes down to 0, and then 1 times 8 is 8. Negative 1 times 3 is negative 3. And you subtract 1 from this, and you get negative 2. Okay, so rewriting this in a cleaner manner, we get 8 minus 3 over x squared. And now I can place my 2 into these derivative functions and finally get my slope. So we put 2 in here, we get 8 minus 3 all over 2 to the second power. And that'll be 8 minus 3 over 4. And let's see, take 3/4 from this, we'll be left with 7 1/4. Or we can say this is going to be 29 over 4. Okay, so that's our slope. All right, now that we have a slope, now we want a point. We have a point and a slope. So let's go get the point by putting 2 into this function here. So f of 2 will be 8 times 2 plus 3 over 2. This will be 16 plus 3 over 2. Well, 3 over 2 is the same thing as 1 1/2. 1 1/2, which gives us 17 1/2. Which also can be written as 2 times 17 is 34 plus 1 is 35. So 35 over 2. All right, so there's our point, 2 and 35 over 2. All right, so we got a point and a slope. So now we pull out our point slope formula. Oops, that should be a minus. Minus x1. Okay, let's bend this down a little bit. Okay, so we're going to put our point in here. So this will be y minus 35 over 2. Our slope, which will be 29 over 4. The x will be minus 2. Okay, so we'll distribute this, and let's go a little higher here. We'll have y minus 35 over 2 equals 29 over 4x, and we multiply these two, we'll get minus 29 over 2. Okay, and then we'll subtract or add 35 over 2 to both sides. So it says y equals 29 over 4x minus 29 over 2 plus 35. over 2. And when we put the negative 29 and the positive 35 together, we should get 6 over 2. Let's see, plus 6 over 2. And hey, that comes out to be a 3. So this implies we have y equals 29 over 4x plus 3 for our linear equation.